So, welcome to my channel Coding Learner. Today we discuss about the queues, and the queues is defined as a linear data structure which works on the principle of FIFO. It means first in, first out. For example, there is a line behind the ticket section of a movie. So the first come will be get the ticket first, and the last one will get the ticket at the last. So this is how the queue is work. So let's move what are the functions of the queue. So first function is and queue. It means that we want to insert the element in our array or queue, and the dequeue function will just like a pop function in our stack. We delete the one element, but there is a two position where the insertion and deletion will be occur. The insertion will occur from the rear and the deletion will be occur from the front, and both times the rear will be incremented or front is incremented, and there is a front function which returns the element which is on the front of the queue, and there is a is empty function as well. It finds that is the queue is empty or not. So it returns the boolean value. So that's it about the functions. Let's move for the implementation. For example, we want to insert 21 in our queue. So our front and rear will be at is -1 and -1, because here initially we didn't have any element present in our queue. So the initial value of the front and rear is -1, and when we inserted one element in our queue, our front will be incremented by 1, and as well rear is incremented as like front. Now let's move. When we are inserted 23 again, we are NQ operation performed. So there is our previous front and rear is 0. So now our front will be remain 0, but during the insertion operation or the NQ operation, the rear will be incremented, and now the rear will be point at the first index, and it saves 23 at the first index of an array. So that's it. Now when we want to NQ 43 as well, now our previous value of our front and rear, our front will be 0 and our rear will be 1. Now it is the insertion operation, thus we need to increment it our rear value. So now our rear value will be at 2. So and it saves the element at the second index of an array, and now the rear will be point at the second index. Now let's move forward. What if we want to dequeue? What if we want to perform the dequeue operation? It means we are deleted one element from the front of a queue. So the front will be point at here initially at 0. So the 0th index element will be deleted, and our front will be printed by 1. So now the front will be point at the first index of a queue, and the rear, there is no changes occurs in the rear because it is not a insertion operation, it is a deletion operation. So only there is incremented to front by 1. So that's it about the DQ. Let's move. What if we want a DQ again? So in the previous slide, our front will be at 1 and our rear will be at 2. So now our first index element will be deleted and our front will be incremented by 1. So now our front and rear point at. So now we are implementing our queues of FIFO principle in the array. So I already declare a micro for this type of a queue. Now I declare a class name as queue, and it has int star array and int front and int rear. So in the public section, there is the default constructor which create array new int type and having size, and our front will be -1 initially, as well as rear will be -1. So that's it. And last, so now we are declaring the various function for our queue. So our first function is AndQ, in which we insert the value or element in our queue. So AndQ will be having int argument. First we check that if our rear is equals to size -1, then it is that. Then we having a out statement saying that queue is empty and break line and it return. If it is not, then we increment our rear one time and we save the array rear index having 12, and now we check if it is a first insertion, then we need to increment our front one time so that it's be at the 0th index of an array. So that's it about the void enq. Now it's time for void deq function. So in these function we didn't need any return value, or we didn't need any argument. We are checking if the front is equals to -1. It means that not there is no element present in our array, or there is one more condition. What if we having a 5 elements in our array and we deleted 5 elements? Now the front will be greater than our rear position. So now if the front is greater than our rear, then we having a out statement saying that q is empty. So it means that we are not able to delete more elements because there is no elements in our queue, and we return. And if it is not, then we increment our front by 1, and we didn't need to change our rear. So let's move for our int front function. Let's take it as peak, which returns the value which is present in the front. So first it's checked if our front is equals to -1 and our front is greater than our rear, it means that the queue is empty. It means that our queue is empty. If it is that, how we print the front of the array or a queue? So we having a out statement saying that no element are present, and we having out statement and then return. And if it is not, then we are returning the array front element. And there is one more function which give the boolean value. Let's take name as is empty. Again we check the base condition. If our element are not present in our queue, then we return -1. Here let's take it, return -1. Here just return true, and if it is not, then return false. So that's it about the functions of a queue. And now we implement our function of queue in our int main. Let's take a queue as q1, and first we insert, let's try to dequeue an array or a queue. Now let's take q1 as is empty, and we're expecting that it is true because initially we didn't push or enqueue any element in our queue. Now we having q dot enqueue function which insert 12, then again q1 dot enqueue function which having 13, and q1 dot enqueue function which is having 1. So now let's check q1 is empty. We're having an out statement for it. Set. Similarly, now we are printing our front element of a queue. We having again out statement with q1 dot peak. Let's take a line break now. And we repeatedly call the dequeue function to delete elements from and queue dot dequeue. Again q1 dot dequeue. Now we are checking that is our q1 is empty, and then we having a line break, and so that's it. Let's run. I hope you understand how these functions are called and how we give the values. So let's run. So when we call our DQ function, initially we having a out statement with saying that Q is empty, and when we again call the Q1 is empty function, just a minute, I have to check it first. Is empty, no elements are present. Empty, just remove it. Let's run again. Yes, done. So in the first function we are popping the element from a queue, so it states that queue is empty. We are not deleted the element from the queue, and now there is a out statement which calling the function is empty. Yes, right now we initially we didn't put any elements in our queue, so that's why we get 1, and when we are inserted 3 element 12, 13 and 1, so when we again call is empty function, then we find that the stack is not empty, that's why we get 0. And then we are having out statement which gives you the peak element or the front of our queue. So initially our front of the queue is 12, that's why we get the 12 in the output. And at the end we are DQ all the elements present in our queue, and then we check that is our queue is empty. Yes, it is empty, and this it gives one true value. So that's it about the queue. Thanks for watching.